This podcast is for educational purposes only. It is not medical advice. Always consult with a qualified healthcare provider before starting or changing any supplement, peptide, or medication. Welcome to today's episode, where we will be exploring the fascinating world of enkephalins. These small but powerful peptides are part of your body's natural system for managing pain, mood, and stress. When we think of enkephalins, we think of the body's own built-in painkillers. They are part of what scientists call the endogenous opioid system. That simply means they are opioids made inside the body itself, not something you take from the outside. So, what are enkephalins exactly? They are short chains of amino acids, usually made of 5 amino acids linked together. The two primary forms are called methionine enkephalin and leucine enkephalin. These names come from the final amino acid at the end of the chain. Despite their tiny size, these peptides can bind to opioid receptors in the brain and body, especially delta and mu opioid receptors. When they do, they can reduce the sensation of pain, create feelings of relief, and even influence emotions. Think about the last time you exercised really hard and felt that post-workout high, the so-called runner's high. Enkephalins are part of that natural chemical cascade. They help you feel less pain, more relaxed, and even somewhat euphoric. Unlike pharmaceutical opioids such as morphine, enkephalins are broken down quickly in the body by enzymes. This fast breakdown means they usually do not linger or create the same level of dependence, but it also means their effects are short-lived. Now, let's dive into their discovery. In the mid-1970s, scientists were searching for natural substances in the body that could interact with the same receptors as morphine. In 1975, researchers in Scotland identified the first enkephalins. This was a major breakthrough because it revealed that our brains produce their own opioids. It opened the door to understanding how the brain manages pain and stress without outside drugs. Enkephalins are not just about pain relief. They also influence mood, learning, memory, immune system function, and even how we respond to stress. For example, when you are under pressure, your body may release enkephalins to help you cope. They act like a buffer, softening the impact of stress on your nervous system. Let's talk about the science behind their action. Enkephalins bind mainly to delta and mu receptors. Activation of these receptors decreases the release of neurotransmitters that normally carry pain signals. That means the pain messages traveling through your spinal cord to the brain get dampened, and you perceive less pain. At the same time, these receptors can also activate reward pathways, explaining why people sometimes feel pleasure or calmness when enkephalins are released. But enkephalins are not only found in the brain. They are also present in the spinal cord, adrenal glands, gastrointestinal tract, and even in immune cells. This wide distribution shows just how important they are for overall regulation of the body. In the gut, enkephalins may slow down motility, which is why opioids in general are linked with constipation. In immune cells, they may help regulate inflammation and the release of cytokines. Now, let's imagine some real-life scenarios. Picture someone getting injured. Pain signals rush through nerves toward the spinal cord. At the same time, enkephalins are released in that region, binding to receptors and reducing the intensity of those pain signals. Or think about meditation, deep breathing, or even acupuncture. Research shows that these activities can stimulate enkephalin release, which may explain why people feel pain relief and calmness afterward. This brings us to the therapeutic potential. Scientists have been exploring ways to use enkephalins or protect them from being broken down so quickly. One approach is to develop drugs that inhibit the enzymes that normally degrade enkephalins. These enzymes are called enkephalinases. By blocking them, you can extend the action of natural enkephalins in the body. Several experimental compounds have been tested along these lines, sometimes referred to as enkephalinase inhibitors. Another approach is creating synthetic analogs of enkephalins that are more stable. These analogs are designed to resist breakdown, cross the blood-brain barrier more effectively, or selectively target specific receptors. Researchers hope this can provide pain relief without the dangerous side effects associated with traditional opioids. Let's also highlight the difference between enkephalins and endorphins. Both are endogenous opioids, but they are not identical. Endorphins are larger peptides, often associated with exercise and euphoria. Enkephalins are smaller, more rapidly acting, and more focused on fine-tuning pain and stress responses at a local level. You can think of endorphins as a broad system-wide surge, while enkephalins act more like precision tools at specific sites. Interestingly, enkephalins may also play roles in addiction and withdrawal. When people use opioids like morphine or heroin, these drugs hijack the natural opioid system, including the receptors that enkephalins normally activate. Over time, the balance is disrupted. That is why researchers have studied enkephalins in the context of dependence and withdrawal, trying to find ways to restore natural function. Let's shift to the role of enkephalins in mood and emotion. Studies suggest that enkephalins contribute to feelings of calmness, contentment, and social bonding. They may overlap with other neuropeptides like oxytocin in creating feelings of connection. This hints at a much larger picture where enkephalins are part of the chemical language of emotions, not just pain relief. Enkephalins also interact with dopamine systems. By modulating opioid receptors, they can influence dopamine release in areas like the nucleus accumbens. This is part of the brain's reward system. That connection is important because it shows how closely pain, pleasure, stress, and reward are intertwined. Now, let's consider enkephalins in the immune system. Research has found that immune cells such as macrophages and lymphocytes can release enkephalins. This suggests that the body uses them not only to regulate pain, but also to help modulate immune responses. Some studies indicate that enkephalins might reduce inflammation or alter the way immune cells behave under stress. This crosstalk between the nervous and immune systems is a cutting-edge area of research. Of course, because enkephalins are broken down so quickly, their direct use as a drug is limited. That is why most therapies focus on stabilizing them or mimicking them. Still, their discovery was revolutionary, and ongoing research continues to explore their potential in chronic pain, anxiety, depression, inflammatory diseases, and even neurodegenerative disorders. Let's take a moment to talk about lifestyle and natural ways to boost enkephalins. Exercise is a big one. Not only does exercise release endorphins, but it also increases enkephalins. Meditation, acupuncture, massage, and even listening to music have been shown to affect enkephalin release. Nutrition may also play a role. Some studies suggest that amino acid intake and balanced diets support the body's natural peptide production. Now imagine the future. If scientists succeed in creating safe, stable enkephalin analogs or inhibitors of enkephalinases, we might see a whole new class of pain relievers. These could provide effective relief without the same level of risk for dependence, overdose, or tolerance that plagues opioid drugs today. That would be a major medical breakthrough. Before we close, let's revisit the big picture. Enkephalins are tiny chains of amino acids, but their impact is huge. They modulate pain, shape mood, influence stress responses, interact with the immune system, and connect to the brain's reward pathways. They are everywhere in the body, quietly regulating how we experience the world. This podcast is for educational purposes only and does not replace medical advice. Always seek the guidance of a licensed healthcare professional before making decisions about your health, supplements, peptides, or medications. Thanks for listening, keep learning, and stay curious.